Hey everyone, and welcome. Today, we're going to pull back the curtain on a super powerful but often invisible science that completely transforms how businesses work. It's all about making things faster, smarter, and way more efficient. So let me just start with a question for you. It doesn't matter if you're running a huge factory or just a small startup. Do you ever get that gut feeling that things could just be better? That somewhere, somehow, you're leaking time, money, or even just energy? Sometimes it shows up as hidden waste. We're talking about materials that get tossed out, or maybe entire steps in a process that don't actually add any real value to the final product. Or maybe it looks like costly delays. You've seen it, right? Production bottlenecks where everything grinds to a halt. Teams just waiting around for parts or information. Basically, people unable to do their jobs. And when you add all that up, what you get is a lost productivity. It's that frustrating gap between what your operation could be doing and what it's actually doing. And trust me, these aren't just little annoyances. They're the kind of things that quietly drain your profits. But what if I told you there's a whole field of science dedicated to solving this exact puzzle? A discipline that's all about finding and plugging these leaks. Well, there is, and it's called industrial engineering. So what is it really? At its heart, industrial engineering is the science of being efficient. It's about looking at a really complex system, think of a busy factory floor, a global supply chain, or even a hospital emergency room, and figuring out how to redesign it to cut out waste in every single form. We're talking less wasted time, less wasted money, and a whole lot less wasted material. And you might be thinking this is just for building cars or something, but that's not the case anymore. Not at all. These principles are used literally everywhere. From making supply chains run smoother to planning your workforce, making sure quality is top-notch, and even pushing forward big changes like Industry 4.0. It's an incredibly versatile field. Okay, so let's get into the good stuff. How do industrial engineers actually pull this off? It's not magic, I promise. It's all about having a toolkit filled with proven, powerful methods and techniques. And this toolkit has a really logical flow to it. First, you've got your analytical tools. These are for seeing and measuring what's really going on right now. Then, once you have that data, use optimization tools to find the absolute best way to arrange things. And finally, you bring in the quality tools to make sure whatever you're making is reliable and consistent every single time. Let's look at a classic one, the time and motion study. Okay, imagine you want to cook a meal faster. You wouldn't just yell, "Cook faster," right? No, you'd break the recipe down. How long does it take to chop the vegetables, to boil the water? By timing every little step, you can spot the holdups and make the whole thing way more efficient. That, in a nutshell, is a time and motion study. Another huge one is value stream mapping, or VSM. The best way to think about this is like creating a GPS map for your entire process. It charts out every single turn, from the moment raw materials arrive to the second the final product reaches the customer. It shows you exactly where things are flowing smoothly and where you've got traffic jams and unnecessary detours. It makes finding a faster, more direct route so much easier. Now, I'm sure you've heard these terms thrown around, Lean and Six Sigma. They're often used together, but they focus on different things. Here's this simple breakdown. Lean is all about speed. It's about cutting out waste so you can go faster. Six Sigma, on the other hand, is all about quality. It's about reducing mistakes and defects so your result is super consistent and reliable. So we have all these cool tools, but what does it actually look like when they're put to work? How does this stuff work in practice when industrial engineers tackle a real-world problem? Well, a typical project is kind of like a full health checkup for your business. It starts with the pre-work. That's all about gathering data, visiting the site, and just getting a lay of the land. Then comes the really deep dive, the study itself. That's where engineers are on the ground, analyzing everything to pinpoint exactly where the inefficiencies are high. And the whole point, the end goal, is always the same: delivering solid recommendations. And we're not talking about a dusty report that just sits on a shelf. We're talking about a clear, actionable plan to streamline your processes, cut out waste, and seriously boost your productivity. It's all about getting tangible, measurable results. So the million-dollar question, does all this theory actually work in the real world? Well, let's take a look at some actual results, because the proof, as they say, is in the numbers. All right, check this out. A major pharmaceutical company, by using value stream mapping, they saw a 30% improvement in their capacity utilization. Just stop and think about that. They could suddenly make nearly a third more medicine using the exact same factory and the exact same equipment. That's huge. Or what about this packaging company? After a study found exactly where their workers were just standing around waiting for materials to arrive, they were able to optimize the workflow. The result? They reduced their need for unskilled labor by 25%. That's a massive saving in operational costs year after year. Here's one from an automobile plant. An IE project gave them a 19% boost in something called Overall Equipment Effectiveness, or OEE. Now, OEE is basically the gold standard for measuring how productive your machines are. It answers the question, how often is our equipment actually running and making good parts? A 19% jump is absolutely massive. It translates directly to more cars rolling off the line and higher profits. And this bar chart tells such a great story. It shows what happened at a textile plant. Through some smart modernization and optimizing how materials flow through the factory, they jacked up their production capacity from 65 metric tons to 85. That's a real game-changing increase in what they can produce, and they did it all without having to build a whole new plant. So yeah, the results really do speak for themselves. This isn't just about making tiny little tweaks around the edges. This is about fundamentally unlocking the hidden potential that's already sitting there inside almost any organization. So what's the big takeaway here? What do you actually get from an industrial engineering study? Well, you get a complete roadmap for getting better. You get specific process improvements for higher efficiency, real operational changes like better layouts, new ways to actually measure your success, and even strategic advice for future growth. It's basically a blueprint for a much more efficient and profitable future. And that brings us all the way back to where we started. It leaves us with one last really important question to think about. When you look at your own work, your own team, or your own company, what is the single biggest source of inefficiency that's hiding in plain sight? And what could you do if you finally found it? Thanks for tuning in.